Another really gimmicky one, but I think it's worth doing. And I'm actually going to talk about what this question is even asking. Maybe pause it and read through it once, but I'll get into it a little more. So what it's saying, or how I made sense of it, is that I just looked at the examples, and so this one's pretty straightforward. We basically just want to remove this this set of outer parentheses and this set. So if you can imagine an algorithm to solve that, basically you'd say define an answer, which is just an empty string, define a counter, and as we loop through, maybe increment our counter here, and if our counter is still at 1, add these, decrement our counter, increment our counter to 1. If our counter is 1, add these, and decrement our counter. So that would take you all the way there. And the tricky part, however, is let's look at this second one. So initially I wrote an algorithm that solved the first one, but had trouble with the second one because, and actually look at this first part. This is actually the exact same as this. So it's this second part that's tricky because we have one opening and then a pair here and then 2 more opening, which gets a little tricky. And the algorithm I walked through for this one wouldn't work for this. So what we need to do is, and I'm just going to start coding that, and then I'll explain it, and I'm actually going to walk through this part and what the algorithm does for this part. So let's call it, and let's give it some room here. Let's call it and let's define our counter. And we want a result to be an empty string. And then, oops. As we loop through, so I'm going to do another one of the newfangled ES6 for loops. But all this is doing is saying for each character in the string. So it's good. Each time we loop through, we're going to get this, then that, then that, then that. So it's just kind of nice for something like this. A little easier to look at, I think. And we're going to say if our character matches that, and I'll explain this one second. What this is saying is, so maybe you've only seen this before, which would be, it's actually the same thing afterwards. We're just incrementing our counter by 1. But with this one, let's jump to the whiteboard. With this one, say our counter, let's say our counter is 0, and then we jump through here and we say let's just say like equals 1. And then let's put it side by side with this one. So this one, when we evaluate this, this says right away increment our counter. So now our counter is 1. And then compare them. So this would evaluate to true. Whereas the second one says check and see if our counter, which is at 0, is equal to 1. So this evaluates to false, then jump back and increment it. So when we go, if it was part of this if statement, say, this second, so these would still be the same as we were working through our if statement, or what we have underneath our if statement. Our counter would still be 1, but for this initial comparison, this gets incremented first to 1, and this we compare to 1 and then increment it. So hopefully that's a little bit intuitive, because you kind of think about it, we want to do this first right away, increment our counter to 1, and then go for it. So that's kind of how I remember those. But I just wanted to show that because I think that's an integral part of this problem, or at least the way this solution is implemented. All right, so I'm just gonna code the rest of this thing real quick. So now if our character equals the closing one, and decrementing our counter doesn't equal 0, and that is actually it. So let's walk through this part. Yeah, example 2. I'm not going to walk through this first one or its counterpart, this first part of this one, because that's pretty straightforward. But let's walk through the second part, and you just have to trust me that the counter is going to be at 0 when we start the second part. So let's go to the whiteboard for that, and let's put it up here. So opening, opening, closing, opening, opening, closing, closing, closing. So our counter is at 0 when we start this. Our res is equal to these 3. I'm just going to leave it as empty because just to make things a little clearer. Let me show you though that I actually have this working. So this is that first example, or the first part of this second example. Let's do oh, I called it S. So that's what we get, which is what we expect. Boom. And just to show you that our counter is 0 at this point. So after we get done with this for loop, and we're just going to return our response. Counter 0, and our response is the 3 matching, or opening and closing parentheses sets. So now we know the state of things at this point in example 2. because it's the same as example 1, the first part of it. So from there, let's walk through what happens in the for loop. So for this first parentheses, if it's equal to this, so if it matches this, yes, and increment counter by 1, and counter, which is now 1, doesn't equal 1. So that is false because it does equal 1. So we don't end up evaluating this or jumping to this part. So else if, so basically or, now that we didn't satisfy this first if our character is equal to that, and notice these and statements, once we get a part of it that's false, so like this, if our character is equal to that, and that evaluates the false, we end things because there's no reason to keep going. So this part of the and. So under the hood, the way that works is if this evaluates to false and we see these ands next, we don't even get to this part, which is important because we don't decrement our counter. So that doesn't get added to our response, which is what we want because we want to remove the outer parentheses. So we can just erase this and jump to this one. And notice our counter is still at 1. So if our character matches this, true, and our counter incremented, so our counter is now at 2, does not equal 1, which is true. We need to add it to our response. So now our response equals that. So next one. If our character equals that, no. If our character equals this, yes, and counter. So -1 does not equal 0, which is true. We need to add that here. Boom, so that does get included. Next one. If our character matches this, true, and our counter incremented by 1. So notice this is the important part. This is sort of the tricky part of this algorithm, is that we need to get to a point to where our counter can be incremented to 2 or even 3, like it will next time around, because therefore we can handle situations where we have a lot of opening parentheses, like this second example. So our counter gets incremented to 2, does not equal 1, which is true, so we add that. So another time it's going to be the same thing, does equal that, our counter equals 3, and we add this because it doesn't equal 1. So the next one is this. If our character matches this, no. If our character matches this, yes. And counter decremented to 2 does not equal 0, true. Add that to our result. Boom. Same thing, no, yes, and yes, because our counter's gonna, I did that a little fast. Decrement our counter first, Now our counter is 1. Compare that to 0. That's not equal. So we add it to our result. Now the last one doesn't match this. We jump here. Our character does match this, and our counter, as we decrement it, our counter is 0. Does not equal 0, which is false. So we don't get down here, and we just leave this out of our result. So this is our answer. And just to show you, I have the second input here. And that's exactly what we get, because if you recall, our first part would have evaluated 3 of these. And then this part, which is exactly what we have. So 4 of these guys, and then the double one. So hopefully that made sense, and this is another helpful video.